On test number 3, the problem that gave me the most trouble was problem number 1. This is the problem that involved a circuit that was assembled and contains a long bulb and a round bulb. And it asks you to find the deflection of the compasses and the degrees of how much they deflect. When thinking of compasses, you need to immediately go to the magnetic field. The magnetic field from the current of the wire is what causes a compass to deflect. When you're looking at certain degrees of the deflection, I thought of the fundamental principle of B wire equals B earth times tan of the angle of the deflection. Also, because you're looking with multiple bulbs in a series and parallel circuit, you need to do the loop equations and the node equations. The loop equations, when you're just looking at the long bulb, is 2 EMF minus the potential difference of the long bulb, which is the current of the wire and the resistance of the long bulb, is all equal to 0. Then when the round bulb is plugged in, it's 2 EMF minus the potential difference of the round bulb, which is the current times the resistance of the round bulb equal to 0. The node equation states that the overall current, or I1, is equal to the current of the long bulb and the round bulb combined. So let's first look at the question when it says the long bulb is unscrewed and the compass deflects 15 degrees. So because the long bulb is unscrewed, you know that the current is going just through the round bulb. So you plug in the numbers. Tan 15 times 2e to the negative 15 Tesla, which is the magnetic field of Earth, equals B wire, which gives you a 5.36 e to the negative 6 Tesla. That's the magnetic field that's interacting with the compass when the current is going through the round bulb. Now let's look at the long bulb. The question states, when the long bulb is screwed back in, the round bulb is unscrewed, the compass on the left deflects 4 degrees. So you plug 4 degrees into the equation to get the magnetic field of the long bulb to equal to 1.4 e to the negative 6 Tesla. So the big question is, where do you go from there to get the deflection of the two compasses on the I1 current? When you're looking at a parallel circuit, you can make the connection because of your connection that I already made earlier of IL plus IR equals I. You can then do the same for the magnetic fields. BR plus BL equals B net. You add that together to get a B net of 6.76 e to the negative 6 Tesla. This is your magnetic field for the current in the main part of the wire, with the compass on the far left and the bottom. So then your final deflection you solve by you have the B wire, which is the number, the B net, and B earth, so you're trying to find tan theta. The degrees I got was 18.7 degrees. So let's look at the final answer. As I said earlier, the 15 and 4 were given to you already from the question. You know that it's going to be the exact thing that they said because nothing else is getting in the way. There's no resistors, there's no capacitors. It's just the two batteries with the current running through here and deflecting right there. The 18.7 is the same on the bottom compass and the upper left compass because it's the same I throughout. It only changes with the long bulb and the round bulb when one is plugged in. Now, the next part of the question is you have to draw the deflection on the wire. So you have to decide, or on the compass. So you have to decide if it would go left or right. To do this, you use the right-hand rule. The main thing that has to be noted is that the question says the compasses are underneath the wire. So the current goes in the current goes in the direction opposite of the electrons. So that would be this way, counterclockwise. So therefore, let's start with the bottom compass first. Point your thumb in the direction of the current, which is to the right. Because the compass is underneath the wire, curl your fingers so they have to reach up and grab the wire. When they go around, your fingers end up pointing toward the left. Or in terms, your fingers are technically pointed away from you. Therefore, you know the deflection is to the left. Now, when you go to these three compasses on the top, you have to notice that your perception is now kind of switched. You're now going from right to left. Therefore, point your thumb towards the left. Flip your fingers so your fingers are up and curl around because once again the wire is on top, so you're reaching over the wire. Once you curl around this time, your fingers are going to be pointed towards your body. So all those compasses will be pointed to the right. The deflections are all to the right on those three compasses because the current is all going from right to left. That should be all for this question. And you really just need to make sure you start at the fundamental principles.